Welcome back to the deep dive. Today, we are standing on, well, the edge of a precipice.
That's a good way to put it.
Usually when we talk about engineering or big construction projects, we obsess over the build phase. The concrete, the steel, the sheer scale of it. It's visual, it's loud.
It is.
Yeah.
That's the visible part. It's the skyscraper going up, the refinery taking shape on the skyline. It's what everyone, takes pictures of.
Right. But we've got a document in front of us today that kind of argues the building part is actually maybe the easy part.
Or at least the safe part.
Exactly. The document is titled Employer Requirement Commissioning and Startup, code number E2.6. And it deals with that.
Yeah.
That terrifying high-stakes moment when you have to take the static sculpture of pipes and wires and actually turn it on.
It's the Frankenstein moment.
Yes.
Genuinely. You've built the body, you stitched it all together, but now you have to channel the lightning.
Yes.
And if you get the sequence wrong or if you missed a single stitch, you don't just have a broken machine.
Yeah.
You have a catastrophe.
That is exactly the vibe I got reading this. It feels like a bomb disposal manual disguised as a technical spec. So our mission today is to unpack it. We're going to figure out why commissioning and startup are two completely different legal universes, really.
Mm-hmm.
We're going to decode the dreaded punch list, and we're going to look at the scope demarcation, which is, I think, a fancy way of asking, whose fault is it if the whole thing blows up on day one?
That is the multi-million-dollar question.
Yeah.
And in heavy industry, sometimes it's a multi-billion-dollar question.
Let's start with the vocabulary, because before reading this, I'll be honest, I used commissioning and startup pretty much interchangeably.
Most people do.
Like, oh, they're starting up the plant or they're commissioning the plant. It all sounded like the same thing to me. But this document, E2.6, it draws a very hard line in the sand, doesn't it?
A rigid line, and for very good reason. Think of it this way. Commissioning is static verification. Startup is dynamic operation.
Okay, unpack that for me. Static verification. What does that actually look like?
So, according to Section 2 of the document, commissioning is all about verification. And it happens during the execution of the works. It's not about running the process. It's about proving that the individual components were installed correctly and that they function in isolation.
So commissioning is basically walking around and kicking the tires.
It's a very, very scientific tire kicking. It's checking that the wiring goes to the right terminal. It's pressure testing a pipe to make sure it doesn't leak. It's bumping a motor for, half a second just to see if it spins clockwise or counterclockwise.
But you're not actually making anything yet?
Not at all. You aren't refining oil. You're not generating power. You're not running the full system. You're just making sure the parts aren't broken before you even try to use them.
You're validating the construction itself.
Precisely.
Okay, so that's commissioning. Then what is this? This RFSU. The acronym is plastered all over the document. It seems like the holy grail of this whole thing.
It is the holy grail. RFSU stands for Ready for Startup. The document defines it right up in Section 1. It's the milestone where all the commissioning is finished, all the safety systems are active, and the plant is legally declared ready to be used for its intended purpose.
Intended purpose. That feels like a very loaded phrase in a contract like this.
Oh, it is. It means you are done checking.
Yeah.
You're done building. You are ready to introduce the hazardous fluids, the high voltage, the extreme heat. It's really the point of no return. The moment you sign off on RFSU, the nature of that site changes, fundamentally.
I want to dig into the who before we get to the how. Section 2.2 mentions a commissioning organization. I sort of assumed the guys who built the plant, the construction crew, would just be the ones to test it. But the document kind of forbids that, right?
It differentiates. It requires a whole dedicated structure. You can't just have the welder check his own weld and say, yeah, that looks good to me. You need a qualified and experienced commissioning team. It's a separation of powers. You need fresh eyes.
And there's a specific call-out in there about vendor representatives. This part fascinated me. It says the contractor must ensure vendor reps are mobilized timely.
Yes, and this is a huge friction point on real projects.
Mm-hmm.
Let's say you got a massive gas turbine from Siemens or GE. That one piece of equipment might cost $20, maybe $30 million.
Right. It's the heart of the entire plant.
Exactly. Now, if you, the general contractor, try to turn that on by yourself and you strip a gear or you overheat a bearing, the manufacturer is just going to look at you and say, you didn't follow the manual, your warranty is void.
Ouch. That's a $30 million mistake right there.
So this document mandates that the vendor rep, the person from the factory who knows that machine inside and out, is physically standing there with a clipboard.
Yeah.
He supervises the installation, he runs the diagnostics, he oversees the testing.
And if he gives the thumbs up and it breaks,
Then the vendor owns the problem.
so you're basically paying for the insurance of having the expert in the room to take the blame if it goes south.
You're paying for expertise, yes, but you are absolutely paying for that liability transfer. And the document notes timely mobilization because you don't want the whole site waiting for 3 weeks because Bob from the turbine factory wasn't booked in advance.
Okay, let's talk about the physical reality of this. We aren't just dealing with clipboards. We're dealing with what the document calls first fills.
Yeah.
Section 2.2 makes the contractor responsible for procuring all of these.
And this is where the budget can really start to bleed if you're not careful. First fills refers to the initial blood of the machine. We're talking lubricants, chemicals, transformer oils, treated water.
It sounds kind of trivial, like topping up the windshield washer fluid in your car, but I'm guessing on an industrial scale, we aren't talking about a quart of oil.
We are talking about thousands of liters of specialized synthetic oils that might cost hundreds of dollars a barrel. We're talking massive tanks of chemicals. And the document is clear. The contractor buys them. If you estimated you needed 10,000 gallons and you actually need 15,000 because of a leak or a miscalculation, that extra cost comes straight out of your profit.
And connected to that is cleanliness. The document mentions flushing, cleaning, and drying. Again, sounds like housekeeping, sweep the floor before you leave, but I get the sense it's a bit more aggressive than that.
Much more. Imagine a high-pressure steam pipe leading into a turbine. If the construction crew left a single welding rod or a bolt or even just a pile of rust inside that pipe,
And then you turn on the steam.
that bolt becomes a bullet. It will travel down that pipe at hundreds of miles an hour and smash into the delicate turbine blades.
Yeah.
You have just destroyed a $10 million asset in milliseconds.
That is a terrifying image. So
Yeah.
cleaning here isn't just aesthetic.
No, it's existential. It means flushing the system with water or air or steam at massive velocities to force every single piece of debris out. It's loud, it's dangerous, and it has to be verified. You literally don't stop until the water comes out perfectly clear.
Which brings us to safety. Section 2.2 lists a bunch of acronyms. AEP, LO, It feels like this whole commissioning phase is way more dangerous than construction.
It is the most dangerous phase, period. During construction, a pipe is just a heavy object. During commissioning, it's a bomb under pressure. You have teams finishing up painting right next to teams who are energizing 11,000-volt cables.
That proximity seems like a nightmare. The document mentions an AEP, an authorized electrical person.
Right. You cannot just walk up to a breaker and flip it because you need to test a fan.
Yeah.
The AEP is the gatekeeper. They are the only ones allowed to energize a circuit. It stops that cowboy behavior where people just flip switches to see what happens.
And LO, lockout, tag out. I know this is an industry standard, but for anyone who doesn't know, what does that look like?
It's a golden rule. If I have to crawl inside a rock crusher to inspect the gears, I put my personal padlock on the power switch. I keep the key in my pocket.
So the machine literally cannot be turned on.
It cannot. Even if someone in the control room tries to start it, the switch physically won't move until I come back, unlock it, and remove my tag. And the document mandates a permit system for all of this. You need a literal ticket, a work permit, to enter these zones.
It's all about controlled access.
Strictly controlled. If you were in the wrong zone without a permit during commissioning, you're usually fired on the spot. It's that simple. Because the alternative is death.
Heavy stuff. Okay, let's pivot to something a little drier, but I think equally critical, the paperwork. Because reading this, I realized you can't just say the plant works, you have to prove it with data.
Oh, yeah. Documentation is the currency of commissioning. If you didn't document it, you didn't do it. That is the mantra.
The text mentions test packages and an EDMS electronic document management system. What is a test package?
Well, to understand a test package, you first have to understand a loop. In a plant, a loop isn't a circle. It's a circuit of control. So imagine a cooling loop. It has a pump, a motor, 3 valves, a pressure gauge, and a temperature sensor.
Okay, so a bundle of equipment that does one specific job.
Exactly. A test package is a folder these days, a digital one, that contains the check sheets for every single one of those items. Is the pump aligned? Check. Is the motor grounded? Check. Is the valve calibrated? Check.
So someone has to physically go to the valve, test it, and then literally sign a sheet.
Correct. And then check the motor, sign the sheet, then check the whole loop, sign the sheet. We are talking about tens of thousands of signatures for a large plant.
The document says this has to be tracked via online commissioning software. Why is the online part so important for the employer?
Transparency, pure and simple. In the old days, a contractor would have a trailer full of binders. If the project was behind schedule, they could just, you know, hide a few binders. Or just
Right.
lie. They could say, oh, we're 90% done, and you'd have no way to verify it without spending a week just counting pages.
Oh, yeah, the paperwork is in the mail.
Exactly. But with an online system, the employer's rep can log in from their desk and see real-time data. You said you were 80% done with the cooling system, but the dashboard says only 40% of the check sheets are signed. It keeps everyone honest. It just removes the ability to bluff.
Speaking of keeping people honest, let's talk about the punch list. Section 2.5. I love this term. It sounds like a list of things you want to hit out of pure frustration.
It definitely feels like that sometimes. But technically, a punch list is just a list of defects or outstanding items. The door squeaks, the paint is scratched, this valve has a tiny leak, this label is upside down.
But the document makes a key distinction here. It separates the commissioning punch list from the mechanical completion punch list. Why split hairs like that?
Because they happen at different times and they refer to different realities. Mechanical completion is, did you build it according to the drawing? Commissioning is, does it behave according to the physics?
Okay, that's a really helpful distinction.
So mechanical punch item might be, you forgot to install the support bracket. It's a visual check. A commissioning punch item is, the pump vibrates way too much when it runs. You couldn't possibly know that until you turned it on.
Now here is the part that felt like a real negotiation tactic, the exception list. The document says these are items proposed not to be completed before RFSU.
This is the reality of mega projects. If you wait for everything to be 100% perfect, you will never start up. Ever. You'll be stuck in construction mode forever. The exception list is a pragmatic agreement.
How does that actually work?
It's the contractor going to the employer and saying, look, the lighting in the parking lot isn't finished, or the insulation on this non-critical drain pipe isn't done. But that doesn't stop us from safely starting the main boiler. Can we put the lights on the exception list and just do them next month?
So it's a way to keep the momentum going.
Exactly. But the employer has to agree. And the document puts strict boundaries on this.
Right.
Section 2.5 says punch list items must be completed before RFSU unless there's a specific agreement. And this is crucial. You cannot put safety items on the exception list.
Right, I saw that. The text says, mandatory recommendations following pre-startup safety reviews shall be added to the punch list.
So you can't exception your way out of a fire hazard.
Never. The engineer will slam the door on that immediately. You can launch with a scratched door. You cannot launch with a faulty fire alarm.
So we've fought through the punch list. We've managed the exceptions. We have reached RFSU. We are ready. Now we cross the threshold into Section 3, startup.
This is where the engine finally roars to life. Section 3.1 defines startup as the period from RFSU all the way up to full capacity operation.
And the goal, according to the text, is to start up in a safe and controlled manner with a minimum of defects. Controlled seems like the key word there. You don't want excitement, you want boredom. Absolutely. In this industry, excitement usually means something's exploding. You want a boring, predictable startup. And to get that control, the document lists prerequisites. You can't just turn it on because the hardware is ready. The people and the manuals have to be ready too.
Yeah, Section 3.2 mentions O&M manuals operation and maintenance manuals. It says they have to be available at least 2 months prior to startup. Why so much lead time?
Because the operators need to read them. You are handing over this complex, dangerous facility to a team of humans. They need time to study the diagrams, to understand the emergency procedures, to learn the control logic. If they're reading the manual for the first time while the alarm's going off, it's way too late.
Which connects directly to the training requirement. The contractor has to arrange operator training.
You wouldn't hand the keys to a fighter jet to someone who's never flown. The document mandates that the contractor, who knows the machine best because they built it, teaches the employer's team how to fly it.
Let's talk about startup logic. Section 3 asks for an integrated startup plan. What do they mean by logic here? It's not philosophy, right?
No, it's sequence. It's a script. You can't just mash all the buttons at once.
Give me an example of that logic.
Okay, take a steam turbine generator. Before you can even spin the turbine, you need the lube oil pump running to float the shaft. But before the oil pump can run, you need the cooling water system on to cool the oil. And before the cooling water works, you need the electrical substation energized to power the water pumps.
So it's a domino effect. One thing has to happen before the next.
Exactly. The startup logic maps out those dominoes. Step 1, energize substation. Step 2, start water. Step 3, start oil. Step 4, spin turbine. If you skip step 2, step 4 destroys the entire machine. The plan has to define every single one of those steps.
Now we get to what I think is the most dramatic part of this entire document. Section 3.5, Startup Scope Demarcation.
Yes, this is the custody battle. This is where the rubber meets the road, legally speaking.
It offers two options, option A and option B. And they seem to fundamentally change the power dynamic of the entire project. Let's look at option A first, which the text calls the default.
In option A, the contractor assists the employer.
Okay, so what does that look like in practice?
It means that up until RFSU, the contractor is in charge. But the moment RFSU is achieved and that notice of completion is signed, the employer grabs the keys. The employer sits in the pilot seat. The contractor moves to the jump seat. They're just there to offer advice or fix things if asked.
So if the employer crashes the plane 5 minutes later,
It's the employer's fault. They took operational control. They are liable.
why would an employer ever want that risk? That sounds terrifying.
Usually because they're experienced operators themselves. If you were a giant like Shell or Exxon, you have your own expert teams. You might trust your own people more than the construction contractors. You just want the builder to get out of the way so you can run your plant your way.
But then there is option B.
Option B is the flip side. In this scenario, the engineer who represents the employer assists the contractor.
So the contractor keeps the keys.
Yes. Even after RFSU, the contractor stays in the pilot seat. They have to start the plant, bring it up to speed, run the trial operation, and pass the tests on completion.
So they don't get their final bonus until the plant is actually making product.
Correct. The employer doesn't take over until the thing is running smoothly and has been proved to work.
This seems like a much safer bet for the employer. I mean, why wouldn't you always choose option B?
Money and time. Option B forces the contractor to carry a huge amount of risk. They have to keep their expensive commissioning army on site for months longer. They have to ensure the plant while it's running. They're going to charge you a hefty premium for that service.
So option A is cheaper, but riskier for the owner. Option B is more expensive, but the builder carries the risk.
Precisely. And there's another factor. Technology. If you are building something with brand new tech, something that's never been built before, you almost always want option B. You want the person who designed it to prove it works before you touch it. You don't want to be the guinea pig.
It's just fascinating how a few lines of text in section 3.5 can dictate the behavior of hundreds of people on a site.
It changes the vibe in the control room completely. In option A, the contractor is looking at their watch, waiting to leave. In option B, the contractor is sweating bullets because every alarm that goes off is their problem to fix.
So stepping back for a second, we've gone from a static construction site. We've brought in the commissioning organization and those expensive vendor reps. We've paid for the first fills and flushed the pipes until they sparkled.
We've navigated the punch list, we've argued over the exception list, and we verified all our test packages in that online system.
We've respected the AEP and the work permits. And then finally, depending on whether we checked box A or box B, someone took the controls and initiated that startup logic.
And if we followed document E2.6 to the letter, we achieved full capacity operation with a minimum of defects.
It really just drives home the point that in heavy industry, the paperwork is just as structural as the steel beams.
I would argue it's more important. You can fix a bent beam, but if you have a chaotic startup with undefined responsibilities, you can't fix that. That's how lawsuits happen, and sadly, that's how accidents happen. This document is a blueprint for safety just as much as it is for operations.
You know, the concept of the exception list is going to stick with me. It's such a useful mental model for life, not just for engineering.
How do you mean?
Well, the idea that you can move forward without being perfect, as long as you consciously define what isn't finished and you make sure it's safe, it's about not letting the trivial block the essential. It's a kind of controlled imperfection.
That's a great takeaway. We often get paralyzed waiting for everything to be perfect.
Yeah.
Sometimes you just need to list the exceptions and launch the ship.
So here's a final thought for you listening. Next time you drive past a massive industrial complex, maybe a power plant with steam rising from the cooling towers, or a chemical plant lit up like a city at night, just take a look at it.
And ask yourself the question.
Was it an option A launch or an option B launch? Did the owner snatch the keys the moment the paint was dry, or did they force the builder to stay in the driver's seat until that engine was purring?
And who was holding the punch list when the smoke started coming out?
Exactly. It changes the whole story of what you're looking at. Thanks for diving deep with us into the world of commissioning and startup. We'll see you on the next one.
If you're interested in the templates, please visit our shop. The link is in the description. Thanks for watching, please subscribe and see next time.